Hi, chemist. This is Ms. Fabrizio coming at you on March 30th for our lesson for the day. So this is the beginning of the week. Hopefully you guys had a good weekend. I'm glad to see you back. So I'm just going to start sharing my screen with you. You're probably wondering why I have safety goggles on and this apron. Well, you'll just have to stay and find out. So as always, I want to make sure you guys are staying in touch with me. So here is my contact information. I also will post it in a link in the description, and then it will be at the end of the video as well. So today we are again looking at the standard, the factors that affect reaction rates. And then our objective for today is I can explain the factors that affect the rate of reaction as evidenced by observing a lab activity. So that gives you a clue as to why I look so rad right now. So we are actually going to take a look into your packet. So we just went over what the objective for today is. Now we're going to move into our little mini lesson. So you guys are just going to click on this video. I'll post the video link in the description, and then it's also going to be in our little learning bundle, which is on Monday, Wednesday, Friday, all of the information that you need for the day. So you'll have your link to the YouTube video, you'll have any external links like this YouTube video, and then you'll have your packet and whatever else you need to complete your lesson for that day. So you're just going to click on this YouTube video, watch this YouTube video. So it's not too long, it's about a minute long. And then you're recording your thoughts and notes below right here in this place. So pause the video now to watch the YouTube video about kinetic molecular theory, and then we'll talk about it in a minute. Welcome back. So you should have watched this video and filled out this portion of your packet for the day. So the main thing I wanted you guys to get out of this video is one, I guess, a review of what the kinetic molecular theory is, and then thinking about how this changes between the molecules in a solid versus liquid versus gas. So how the molecules are interacting in that video, I was pretty good at explaining and visualizing what the different molecules in the different states of matter are, so how they're behaving in a solid versus liquid versus gas, and how that translates into just how those states of matter are likely to behave in general. So if their volume is constant or not, if they're how they're interacting with each other, like the molecules within the state of matter itself. So I wanted you guys to take that away. So now we're going to move on to our lab for the day. So that's why I'm just like this. Nothing really dangerous is going to happen. I just am better safe than sorry. So I'm wearing my mom's apron and some of my dad, who's an electrician's, work glasses that are actually prescription. So I guess we'll see if my eyes get damaged after this. I hope not, but we'll see. So shout out to them. This video is sponsored by them today. So we are going, I know we've done labs with Alka-Seltzer already. So I went to the store today, picked up some Alka-Seltzer, and we're going to do this activity. Well, you guys are going to watch me do this activity. And if you have these, I have put the lab protocol, so what the procedure and what the materials you need all in your lab packet. So this is a safe activity. Just make sure you're protecting your eyes, protecting your clothes, so that you're staying safe. So you guys can do this at home if you are willing to, and your parents obviously are willing. If you have some Alka-Seltzer, ask your parents. Don't just be using all this stuff because they might need it. A little background information. So we want to make sure that we're following the directions on what's going on, how to take medication. So especially right now with everything that's going on with the coronavirus, people are getting the flu, you should be listening to the directions from your doctor and on the label for how best to take medication. So for example, with Alka-Seltzer, is it better to just swallow the whole thing whole? Should we dissolve it in water first? Should we break it up and then dissolve it in water first? Should we break it up and then swallow it? What's going on? And same thing with other types of medication. So we need to know how best to take them, that they're best going to work, meaning how quickly. The quicker they work, the better they'll solve whatever they're supposed to solve, whether it be pain, maybe acid in the stomach, maybe heartburn, stomach ache, whatnot. The quicker that we can alleviate that pain, the better. So this is things that chemists who are creating pills, who are creating vaccines, who are creating different things are thinking about. So our little pre-lab before the lab video, I have the Alka-Seltzer picture in your packet, and then also a like the labeling on the packet. So read the label right here. So take a minute, pause me to do that. Tell me what the active ingredients are, what the inactive ingredients are, and what the suggested directions for use are. So all from this video, from this label right here, you should be able to answer A, B, and C of step 1. So pause me right now, take a minute to do that. Okay, welcome back. By now you should have completed step 1, A, B, C. So tell me the inactive ingredients, the active ingredients, and suggestion directions for use. So that's great. So now step 2, we are going to predict what's going to happen. So today we are going to observe how Alka-Seltzer reacts with just normal tap water and varying like factors. So 1, we're going to increase the temperature. 2, we're going to increase the surface area. 3, we're going to increase the concentration. And then 4, we're going to stir and shake a little bit of the Alka-Seltzer. And then we'll have a control where we don't do anything special to it. So right now, predict the effect on the reaction rate for each of these factors. So you have this whole table to fill out at the bottom of page 2 under step 2. So based on your understanding of how temperature, surface area, concentration, and stirring and shaking are going to affect a reaction, thinking about, is this causing more collisions to happen? And more collisions means what in terms of reaction rate? So pause me right now to complete step 2 on the bottom of page 2 and tell me how all these factors you think are going to affect the rate of your reaction. Okay, welcome back. So by now you should have completed the table at the bottom of page 2. So you should have predicted what you think is going to happen when we increase the temperature, the surface area, and concentration, and add stirring or shaking to our Alka-Seltzer experiment. So now on page 3, I basically just have the whole procedure for you. So it lays out what we're doing. So we're going to observe how quickly the Alka-Seltzer water reaction, I'll blow the top off of this pill bottle that I have. So I don't have a film canister, so I'm making do with what I got, as we all are in all aspects of life right now with all the quarantine stuff that's going on. So I'm not going to twist it on because I don't think it'd be able to come off, but just lightly placing the cap on this pill bottle and see how quickly the Alka-Seltzer is able to bubble it off. I'm going to use my phone as a timer. And yeah, so we're gonna perform 5 different tests right now. So we're gonna do control, meaning we just need this as our baseline. So what is the typical time it takes half an Alka-Seltzer to blow the top off of one of these? So we just have a baseline. So we see when nothing is being manipulated, none of these variables that we're looking into are being manipulated, what is the base comparison? Then we're going to increase the temperature. All the other, except our test B are going to have room temperature water. Test B is going to have hot water that I got from the tap water. So just feeling it, I know you guys can't feel it. This one's a lot warmer. It's actually making me quite warm in my room right now. Experiment C, we're going to increase the surface area, meaning we're going to break up the tablet more. So more parts of the tablet are coming into more direct contact with the water, and see how that affects the rate reaction. We're going to stir and shake. So I'll shake up the little film canister to see if that has an effect, and then increase concentration. So we're going to put more of the tablet in. So we're using half the tablet for every other test except part E. And then for part E, we'll use an entire tablet to see if that changes our rate. And then on page 4, the top of page 4, this is what I suggest you be on while you're watching me perform these different tests. So whether you're going to watch me and type it in or you have it written out, this is what I suggest you be on so I can show you the number for each test. So part A, B, C, D, or E. And then you record the time and any additional observation. So if you saw something funky happen, if I say something that you think is important, you should write it down. If I say something important, I will let you know to write it down. So yeah, we'll get started. So we're gonna do our control first. So I already have room temperature water in here. So let me stop sharing my screen so you guys can get a full-on view of this. Should have had these prepared ahead of time. That's my bad. So that one's gonna be the one that we use as the broken up one. Okay, so I will hold it up for you guys to see. And I'm gonna start my timer. So it's definitely bubbling, as you guys can see. It hasn't blown the top off yet. Okay, so I would just put that one as a like I stopped it at 48 seconds. So you can put it at 48 seconds for part A. I'm gonna now do our hot water experiment. So I'm gonna put the hot water, 15 milliliters, which is roughly equivalent to a tablespoon. So I'm using what I got. So a tablespoon of hot water. We're gonna use another half of an Alka-Seltzer. I'm gonna reset my timer. So we have hot water now. You can see it's bubbling up more. So it's definitely increasing its rate of the reaction. It came up higher. It too, it must not have enough of momentum or enough bubbling of the gas to blow off the temperature, but the reaction stopped a lot quicker than that other one. So let's say that that one was about 30 seconds. So that's what I have on my timer. So 30 seconds for part B. I'm gonna add 15 more milliliters of the water. Now let me just see what our next reaction. So we're gonna do increased surface area. So that means we're gonna break up the Alka-Seltzer tablet. So I'm going to reset my timer. I'm going to crush up a lot of my Alka-Seltzer tablet. So instead of big pieces, I'm gonna do smaller pieces. Drop it in, start my timer. You again can see that this reaction is happening quicker than the first one. We see that our bubbles are going up higher. We see that it just happened generally quicker. So again, I guess this reaction isn't having enough momentum in the gas bubbles to blow the top off. So we're basically just gonna time it to when we stop seeing bubbles like actively forming. Okay, so it's definitely slowed down. So that one we're gonna clock at about 42. Let's do 42 seconds. So I'm going to restart this. Add 15 more milliliters of our water. Okay, so this one is test D. So now we're going to do our stirring. So I'm going to start. So definitely more bubbles forming. So we were able to create more collisions between the water and the Alka-Seltzer tablet to create more bubbles, and look how high they're going up. The bubbling has definitely kind of reached a tip. So now it's definitely starting to slow down. Okay, that one too is about a 43.25 if you want to add the 25. Okay, so now we're moving on to our final test, test E. So that's going to be a whole Alka-Seltzer tablet into the canister that we're using. So I'm going to reset our timer. We're going to add a whole Alka-Seltzer tablet. That one definitely is coming the highest up with the bubbles that we've seen. Definitely a lot of bubble action going on. And I'm going to redo test A because I was hoping that the remainder of the test would blow the top off, but now I'm seeing that that's not the case. So I'm going, since I've been testing them kind of at how quickly they're able to use, like dissolve all the Alka-Seltzer versus the others, I'm going to redo the first one as well. Okay, so we'll clock that one at about 42 as well. Even though it's still bubbling, it kind of started tapering off a little bit more. So I'm going to redo test A for us, just so we have a better, more complete experiment. So having them all sort of, oh, this one sort of broke off in a good place anyway. Let's just stick a little bit off. For the rest of our experiment, we got to make sure we're consistent with the way that we're recording. So I'm going to start the timer. As you can see, this one is not bubbling nearly as high as I don't think any of the other previous ones. So it tests B through E. And it's still going, pretty slow bubbles forming. It's still bubbling. And it's coming to an end. So I would say that our clock was at about 1 minute, so 60 seconds. So no, sorry, I didn't mean to stop the video. So now I'm going to share my screen with y'all so that you can see. I'm going to take my goggles off because I do think that prescription while I'm wearing contacts especially is hurting my eyes. So you guys should have the top of page 4 all filled in. If you haven't, feel free to rewind me, pause me, do whatever you need to do to complete that. I'm going to change the rhetoric of this so you guys have more of a better idea of what you need to do. So since the top of the canister didn't fly off, we just were kind of measuring how long it took to kind of taper off and not be bubbling as quickly. So you guys should have filled this out, filled any additional observations. So maybe at how high the bubbling was getting to. Like some of it was kind of slow, and then the more, especially for part E, when we have increased concentration, so a larger amount of the tablet, it got a lot higher. So now we're going to move on to our analysis. So you guys are going to refer back to your predictions in the pre-lab. So it's referring to the bottom of page 2. So what you predicted for increased temperature, surface area, concentration, and stirring/shaking. You guys are going to compare the control experiment. So control A, meaning we didn't manipulate anything about it. That was just room temperature water with half a tablet of Alka-Seltzer, and that was it. So we didn't change any of the variables. We didn't make it too hot. We didn't make it higher concentration. We didn't shake it up or anything. So that's what that's referring to. So compare what we saw in time seconds to control A to each of the others the different variables that we were referring to. So part B, we were talking about increased temperature, surface area for part C, concentration for part D, and then stirring/shaking for part D. I'm sorry, I misspoke. So increased concentration was part E. So compare the control data to the rest of them, basically, is what you're doing. So pause the video right now to compare what we got, like how long it took for our Alka-Seltzer to react completely with the control versus the other variables. So you guys are writing an analysis number 1, completing that right now. So pause me to do that. Welcome back. So by now you should have completed analysis question 1. So now you're going to complete analysis question 2. So describe on a molecular level what is happening as we increase the 4 factors that we did for this experiment. So you can include a diagram if you want and be specific for each factor. So as we're increasing temperature, what's happening at the molecular level? How is this changing the collisions that are happening in the molecules? So think about the molecules of water reacting with the molecules of the Alka-Seltzer. What's happening? So when we increase the temperature, the surface area, and the concentration. So you guys are filling out the table that I have highlighted. It's at the bottom of page 4 and the very top of page 5. So pause me now to complete that. So welcome back. You should have completed up until analysis question 2 on page 4 and 5. So you should have told me what is exactly happening when we change temperature, surface area, concentration, and add stirring or shaking into a chemical reaction, how that changes the collisions and the rate of the reaction. So finally, we have our extension activity on page 5 and 6. So this is just a little solidification analysis question for you guys. So we're talking about aspirin here. So we just did our experiment on Alka-Seltzer, which is something that people take when they have upset stomachs, when they have heartburn, indigestion, body aches, everything like that. So this question is kind of hitting very similar to that. So aspirin for heart attack, is it better to chew it or just to swallow it? So this is an article adopted from a Harvard article. So you guys are going to read what's on page 5. Just a little scenario telling you. At about page or number 5 and 6, it starts telling you kind of what's happening, like what's the science behind, what's the chemistry behind these, behind aspirin and what's going on. And then you are answering this question on page 6. So in the data in your lab that we just performed, is that consistent? So think about the Alka-Seltzer lab. So is breaking up the Alka-Seltzer, do we find that it is similar to what this data is showing you and what this data table on page 6 is showing you? So it shows us a chewed up tablet has a quicker reaction rate. So it's able to get the desired effect quicker. That's what this red line is showing us, than just aspirin dissolved in solution. So if we dissolve an aspirin and then we ingest it, or if we dissolve an aspirin and just ingest it with this blue line, and then with the silver line, it's just a swallowed tablet. So we see that the dissolved aspirin and that the chewed up aspirin are more effective than just swallowing an aspirin because it increases the surface area, right? So is this consistent with what we just found with our Alka-Seltzer lab? So you guys are taking this final pause of this day in chemistry to answer this question. And then remember, as always, to support your claim with evidence from the text that you read on page 5, that you're reading on page 5, and then the lab that we just completed. So pause me now to complete that, and then you'll be done for the day. Good job, you guys. So pause me. Okay. Welcome back. My cat is very eager to get in the video now. He is acting a fool right now. So you guys are all done with that. You should have completed up to page 6 for Monday on March 30th. So good job. Congratulations with that. So I'm real proud of you guys for getting through with it. Here's just a look ahead to our week. So we're going to have a Google Hangout tomorrow, which is Tuesday, March 31st at 10:30 a.m. I will post the Google Hangout link in Google Classroom. And then, as always, we'll have a new upload on Wednesday and Friday, and then another Google Hangout on Thursday. And then finally, here's just my contact information. Make sure you guys are communicating with me. Please turn in your packets so I see where you guys are at. Please turn in mini QPA. I'd love to hear from you guys. So good job today. You made it through the end of the video. I know this was a long one. Thank you for bearing with me. See you guys next time.